There are two main pieces to population forecasting: the design period, or how long we want your system to work, and the actual forecasting formula you want to use. 30 years is a common design period for pipes, but be aware that different items may have different design periods. For example, pumps may need replacing and resizing every 5 to 10 years. So all you need is to find out the current population, the past growth rate, and decide on a project lifespan. Now, not all populations are growing, some of them are actually shrinking. Many rural populations are declining due to migration. Globally, urban and total populations are growing, while rural populations are on a small decline. This is the geometric formula, one of the most widely used forecasting methods, especially for rural and smaller systems. The formula compounds the incremental growths. For example, for a population of 2,000 over 30 years growing at 3%, it renders almost 5,000 people. Personally, I like to work with coefficients, so I run the formula for an initial population of 1, which I find is more visual and practical to use. In this case, for each person in the beginning, there will be 2.43 at the end of the design period. The limitation of this method is that it produces an accelerating growth forever, and we all know very well that that's not possible. At some point, the growth has to come to a stop. There are many forecasting methods that try to account for this slowing of the growth, and there's also the possibility of disaggregating predictions for different groups, so it's easy to get lost, but let's review one that I find very practical for urban settings. The growth curve will take an S shape and tend towards a limit. For humans, that limit is frequently a population density from which we stop tolerating each other, or it's not worth the trouble. That limit is particular to each setting and place, but observing nearby populations will give you a clue. Maybe it is 600 people per kilometer square. Finally, I think it's a good idea to double-check the figures we get from censuses with satellite images. For instance, I was once given a population of 4,000 for this 200 people village in Haiti. 4,000 was the district population that just happened to have the same name. Satellite images can give you also a very accurate idea of growth rates. Here I use Google Earth to compare the house count for two different dates for the same village. That, combined with a simple ground household survey to see family size, the number of deaths and births, and the migration balance, can give you a very precise idea of growth rates.